Hello, good morning, good afternoon, or good evening, wherever you are. Welcome to Spantech ACD's presentation on gas generation using gas generators. I hope you can hear me. Please say hello in the chat box if you can. It's always reassuring to know that I'm talking to someone rather than no one. I can see a few marks coming in. Always nice to hear where you're speaking from as well around the world. So say hello from Bangalore or hello from Berlin. It's always good to see that. I'd like to just do a very brief introduction to start this meeting. But the main part of this hour session will be devoted to Kurt Ballard from ACD talking about the gas generators. So very nice here from Singapore. I can see people, Sweden. Hello, Peter. And Michael from Singapore, lovely. So nice to see some people up from Arthur's from Poland, so that's brilliant. Bogash, I can see, fantastic. Good morning, Bogash. Always good. Let me start. I want to keep on time today if we can. Try and get the camera to work, hopefully. I will, so you can see who's a real person here talking. I will give you a very brief start, and in 2 or 3 minutes we'll be into Kurt. So you should be able to see at the moment just an introduction slide, which I'll move forward. I want to briefly talk about Spantech. For those of you that don't know Spantech, we were founded in 1977 by Dr. Chandramani Narain, my father. We've operated since 1977. Since 1984, we've been based in South Godstone, Surrey, which is in the south of England. South of London, not far from Gatwick Airport. If you know Gatwick Airport or know where it is, we are one-stop shop for calibration gas solutions. In that we have various different calibration gas products. We have sister offices in Poland, in Calcutta with Spancan, and with ACD in Tucson, USA. A lot of our major markets historically have been export, although we obviously do sell other products within the UK as well. Products that we've historically done for the last 25 years have been calibration gas cylinders, gas sensors, rear gas purifiers, and what we're going to talk about today, which is, Kurt will talk about, which is the calibration gas generators. We're linked to ACD in a number of different ways, being a master distributor. We have a calibration centre now open in the UK for a quicker turnaround, particularly for the European customers, as well as an additional pre and post set technical support centre near Cambridge, which officially will open on the 1st of January next year, although it is in operation as we're training at the moment. And that's in particular, that centre is set up for online demonstrations and troubleshooting, so that we can show the product off, demonstrate product, but also deal with any issues that may arise after sale. Which is basically the relationship between the companies. So the rest of this presentation will be handled by Kurt. Kurt is the president of ACD. ACD has been producing generators for 30 years, based in Tucson, Arizona. And Kurt has worked for ACD for much of that time. He can introduce himself. But currently the president of ACD, and has a long history, particularly on the originally with the service side, and now in every part of the company. This is the first of a series of seminars that we plan to do, one every 2 months. We'll do, January we have a plan to do gas sensors, and we will send out information on that when that is finalized. These are technical lectures aimed at providing information rather than marketing slides. That's one of the key goals. With that, I'd like to turn to Kurt and turn over the screen to him. There will be 3 polling questions that will come very shortly. I mean, these are just opinion poll questions that we get a flavour of who you are as an audience. They're very simple questions, but it allows us to understand the audience needs. The first one should be on your screen at the moment. I can only put 5 gases up, so I tried to pick the 5 which I thought were most likely, and then there's a couple of other yes/no questions to follow. But on that, I'll hand over to Kurt.
Good to see everybody here today. As Chris mentioned, I'm the president of Advanced Calibration Designs, and we've been building these calibrators for gas detection equipment for the last 32 years. We've been started off with, as back in those days, to make chlorine calibration gas. Back then you couldn't get it in cylinders. And so we came up with a novel idea, our founder, of how to generate these gases on demand rather than using a compressed gas cylinder to use to calibrate your gas detector. So we kind of stayed in the toxic or slightly explosive gas area. And what we've made are handheld battery operated calibrators for gas detection equipment that are primary standards, and these things are used to calibrate sensors. We don't have calibrators for every single kind of gas, but the ones we have are adjustable and, as it says here, dependable calibration gas standards. Now we have a wide variety of calibrators, all the way from very low cost bump testers to very exact high-end calibrators. You see here listed the various gases that we generate, and so these are a glimpse here of what gases you get with what instruments, the big advantage of these things is if anybody there has used cylinder gases, you know they're expensive to ship and they have shelf lives, and these are non-hazardous to ship. They don't have shelf lives, and they're environmentally friendly and cost effective. So it's a novel approach, even though it's a 32-year-old idea. A lot of people haven't heard of our product, so we're trying to get the word out there and show the advantages of being able to generate the gas on demand rather than store it. So here you see some of the ranges. This is more specific on what outputs we can get with what gases we have. So you see, for example, the GENie EC unit is used for ammonia. So its range is anywhere between 10 and 500 parts per million. One of the unique things we also have that cylinder gases don't have is the ability to do parts per billion. And you can see, the hydrogen cyanide, hydrogen sulfide units go down to 0.05 parts per million. So that's 50 parts per billion. So we can make very low, very accurate amounts of calibration gas. And again, these are not stored under pressure, but rather generated on demand when they're needed. And this gives you a reference to what instrumentation we produce that makes the specific gases that you're looking for. These instruments have built-in pumps rather than, a compressed gas cylinder, you put a regulator on the top and the gas comes out. These instruments have pumps inside them, and you can set the flow rates, and you can see those vary also, so that you can match up to your specific sensor, whatever that manufacturer recommends to calibrate their sensors. That's what you can set your instrument to give the output you want. And you can vary them. So if you have a certain brand of sensor that wants, let's say, 5 parts per million chlorine at 0.5 liters per minute, you can calibrate all those, and then you can change the output without buying a different cylinder. For example, you just change the output to 10 parts per million, 1 liter per minute. If that manufacturer says that's what they recommend for their calibration. So these are flexible gas generators. Now, back in the old days, you used to use these calibration gas cylinders. As you know, especially for the corrosive gases, they're unstable. You can't recertify a cylinder, you just throw it away. You get one concentration in a bottle, and they're hazardous to ship because they're compressed gases. There's also the permeation tube, which is a tube of pure gas, say hydrogen sulfide, for example. And then there's sort of once you break the seal, the gas permeates out, and these instruments are highly temperature dependent. There's a lot of power consumption. You can't turn them on or off. They're okay in a laboratory setting where they've been able to stabilize for a couple of days at a time. And then, of course, because it's pure gas in a permeation tube, they're hazardous to ship. So there are problems with those types of calibration solutions for your gas sensors. The way most of ours work are electrochemically. So the principle is Faraday's law of basics in chemistry is you pass a certain amount of current through a galvanic cell like this, and you generate so many molecules of the gas that you're trying to make. So that's what everything is based on that we use to generate cal gas on demand. So some of the advantages of this, as we're talking about here, how to generate gas on site, is, as I mentioned, you can change flow rates and concentrations. You can make some gases that cannot be stored in cylinders. The examples there are ozone and chlorine dioxide. Chlorine dioxide is explosive if you compress it. And so the only way to make it is to generate it on demand. And you'll find that one of our generating sources can produce a very large amount of calibration gas. The sources last for years, and the instruments are portable and easy to use. There's user interfaces and displays in the instrumentation that walk you through how to set them where you want them to calibrate the equipment that you're using. Some other things about these calibrators: you can pop different sources in and out. So you can insert a chlorine dioxide source into one unit. You can take it out, sort of like an inkjet cartridge into a laser printer. You take one out, put another in, so you have one instrument and you can generate several different gases. We have instrumentation that is ATEX certified and CSA for Class 1 DIB 1 areas. So if you have a hazardous location like a refinery, the instruments we have are CSA certified so that they don't cause the spark in that area, so you can use them in hazardous locations. We also use the ambient air in the room, bring it into our instrument, and then blend it with whatever calibration gas you want. Say it's nitrogen dioxide, and we feel that's the most accurate way to calibrate a sensor, rather than a permeation tube, or in a cylinder. Typically a corrosive gas like NO2 is going to be stored in nitrogen, and so it's no humidity, pure nitrogen, and the sensor will react a little bit differently to that than it will the ambient air in the room with its relative humidity blended with the calibration gas that you're looking for. In our case, we're talking about NO2 this time, but that's the most accurate way we believe to calibrate. That would simulate what a leak in that room would look like, right? The instrumentation is also self-monitoring, so it's watching itself and make sure the flow rate and the current is correct all the time. And again, these things are non-hazardous to ship and store, so it's a nice advantage over permeation devices or cylinder gas. So here's the cost advantage. We just show a quick example. These are in US dollars, but you get the idea. We have this varying amount of gas that can come out of a source that we have. So they go all the way from a source that lasts for 2 hours up to 500 hours. And we compare cylinder cost versus our generating cost. So if you purchase one of these instruments, the upfront cost is more than, say, a cylinder gas or a permeation tube, but the cost per calibration is much lower once one of these instruments and generating sources has been purchased. So one generating source, can produce as much gas as up to 100 58-liter cylinders. So they're very cost effective once purchased. So I go into a bit of different families of gas generators we have. This is our high-end unit, which has the most flexibility. They're rugged. They can expand to many different gases. Every gas that we can do in this family we call the GENies. So one modular instrument, and it gives us every kind of gas we generate. You see the ozone unit there. We can also do chlorine dioxide in this, in every gas we have. And they are expandable and integratable. So speaking of the ozone unit, this one, the source, instead of being a galvanic cell, is a lamp. And so every 100 hours of use, this unit will tell you to send it in to get it recalibrated. But if you've done much calibrating, 100 hours of cal gas is a lot of calibration gas. So this one, you can select the output. The range is 0.2 to 1 liters per minute. We have English, French, German, Portuguese, and Spanish user interfaces, so you can select the language it's in. We get at least 500 hours of calibration gas out of this unit. And so it's a really long-lasting calibrator. Here's the specs on that unit for anybody interested in ozone. The difference between our generators and a cylinder is it does take them a minute to stabilize. So you can see the warm-up times here, about 2 minutes. So you turn it on, it starts to generate gas, but it's at its T90. It's at 90% output within 2 minutes. The airflow is variable. These things run on 4 alkaline batteries. You get about 8 hours out of that. All of our instruments also have mains power adapters, so you can plug them in to main power if you're not walking around a facility. Generally, all these instruments are used portably, and people walk around a building and use them. But if you do sit at a lab bench and calibrate, you can just plug them right in and never use the batteries. The EC stands for electrochemical. So this is the variation of the unit that uses the electrochemical generating cells. So there are several different cells that can be popped into this one. We have 10, 50, and 100-hour cells for these. Again, English, French, German, Portuguese, and Spanish in this one. And so here's the different gases that are available in this unit. So you buy the EC module, and then you purchase the gas or gases that you want. So you could buy one of each of these if you had all of these gases, you can get one. Again, there's a warm-up time. It takes about 5 minutes. The instrument tells you when it's ready. There's a user interface that shows you. And 4 AA batteries last about 10 hours of cal time, which again is a lot of calibration. And then this is the QC1 version of this GENie. It generates ammonia. The source for this is a vial. We call it a QCV vial. This goes all the way up to 500 ppm of ammonia. We've got the several languages on this one, the same as the other. And you see this variable output and flow rate. You get 1,000 ppm hours per vial. So you can start with your high range, say 500 ppm sensors, and then go around the facility and calibrate all your life safety sensors that may be set to calibrate at 25 or 50 parts per million. And again, should get at least 8 hours out of the setup of batteries on this unit. This instrument is the Cal 2000. This one is a CSA certified unit, and so they can be used in hazardous locations. Again, this one came out in 2000, so this has been the workhorse of our company for the last 20 years. I'll show you next the list of, there's what the generating sources that plug in look like. I think that's the first picture I've had of those. But those insert into the unit, and then each one of them has a memory chip. When you put it in the instrument and turn it on, it tells you how much life is left on that particular generating cell, and the instrument reads it and knows what polarity to set the cell at to generate the gas you want, and how much current to pass when you tell it what concentration and flow rate you want. So the cost effectiveness, you can imagine one of those little generating sources makes as much calibration gas as 100 cylinders. When you buy one of those cylinders of gas, you're buying 99.9995 usually % air. And so you can see why one of those little generating sources can produce up to 100 hours or 100 cylinders equivalent worth of calibration gas. It's a very cost-effective and flexible way to make calibration gas. Now this Cal 2000 instrument, again, microprocessor controlled. It's got an internal mass flow sensor. The keys to generating gas on demand, as we're talking about in the seminar today, is you've got to have the flow rate that you blend the gas with right, and you have to have the current passing through the generating cell correct. So this instrument has an internal mass flow sensor so that it adjusts for air density. So it doesn't matter if it's cold or hot, or if you're up on top of a mountain or at sea level. The instrument knows what the density is of the air and compensates to make the calibration gas exactly what it's supposed to be. These units can be used with sensors that are diffusion based, or sensors that have internal pumps that draw through them. You can shut off the pump on the Cal 2000 and allow the sample drawing pump to pull the sample in, or you can set the flow rate that you want if it's a diffusion based unit and calibrate it that way, like a cylinder would. This is the unit that's CSA and ATEX certified. These are all traceable to NIST, so these are primary gas standards, and we have down to ppb ranges in chlorine H2S and NO2. So there's the gases and ranges for this particular unit, just to show you what might apply for your application. Runs about 10 hours on batteries. We've got plus or minus 10% accuracy, or plus or minus 5% on repeatability on this unit. We also have a LT version of this. This is kind of the Cal 2000 Lite, if you will. we had in the early 2000s, we had some customers who asked if we could make one of these things that was not adjustable. They thought we had too many bells and whistles. They were worried that their calibration technicians might make a mistake and set the concentration or flow rate incorrectly. So they asked us to make one that was prescriptive. So on this unit, when you order it, you either order a half a liter a minute or 1 liter per minute of cal gas flow rate. And then when you order this generating source, you tell it what you want, 1 ppm, 23 ppm, whatever it is. And then we set that to it. When you put the generating source into the instrument, you turn it on, it just runs at that flow rate and output. So it's similar to a cylinder, except it's either 10 or 25 hours of gas, but the user cannot change the output, and it's fixed. So again, microprocessor. This one is also CSA and ATEX certified, and this one's a little less expensive, and it has less features than the Cal 2000. We don't do every gas in this one just because of the complexity of some of the gases, but these are the gases we do. And again, you just order whatever you want. You know, hydrogen cyanide at 8 ppm, half a liter a minute. And so that's how that instrument works. We also have some bump testing instruments. Depending on your safety person at your facility, a lot of people will calibrate at a set time interval, maybe every quarter, every month, every year. And in between, they'll want to bump test or functionally test the sensors to make sure they're working. So this little instrument here can do either. It can either be a calibrator or it can be a bump tester. The sources that go inside of these will last for 350 bumps or 5 hours of continuous calibration gas use. And this one has CSA and ATEX certification as well, so it can be used in a hazardous location if needed. Now on the bump side, so these are just the bump test cells that don't put out an exact amount of gas, they just bump some gas. These are about what comes out of there. So the chlorine comes out about 5, hydrogen's about 25, HCN at 10, and H2S at about 25. What happens is you just press the button on the front of that, it runs on 2 AA batteries. It passes current through the cell for a minute, and then a pump inside kicks on and pushes some gas out. And we're just going to functionally test, make sure that sensor's working or that gas detection system altogether is working. So you can make sure all the lights come on and the sirens sound and everything is working as you want it to be working on a functional test, but not set the exact ppm level of your sensor. There's the bump station. You can buy this thing set up in a hard enclosure so that it's, you know, these are mostly seen in refineries and on ships and things, and so it's set up there. You walk up, you press the button, you hold your gas detector in front of it, it starts to beep, and you walk away. It shuts itself off after 30 seconds, and the next guy coming through, a lot of times they're mounted at the guard shack where you come onto a facility, and they're just bump testing. A lot of times these are used for go, no-go, little sensors that are clipped to the hard hats at refineries and shipyards and things like that. Here's another bump tester we have. It's called the QC50. We've got these in some other gases that we could not make good calibrators out of. So at least we have a way to check. You see that vial that's in front of the unit. Inside there is a sealed glass ampule. And what you do when you're about to use this thing is you break that ampule, you insert it into that unit right there. This is a very low cost unit for functionally testing sensors. And then there's a little squeeze bulb there that you just squeeze to deliver gas out. It comes with a hose that attaches on the end of it. And you put your calibration cup on the end and functionally test whatever gas it is. So these gases are different than the other ones for the mini bump. So this is the gases we can do here: ammonia, hexane, HCl, and toluene. These vials we rate for an 8-hour shift. So once you break that vial, we'll say you can bump test all the sensors you want for an 8-hour shift. Eventually, they do permeate out and evaporate, and then you don't get any more gas out of them. The next month or the next quarter or however, the next week, you break another vial and go around and bump test all your sensors again. And the QC100 is basically a motorized version of the QC50. So that knurled knob on the outside is a course adjust. You press the button, turn it on, there's an internal pump in this unit. And you walk up to your first sensor and open that course adjust knob until it alarms. And then you can walk from one to the next, and you don't have to keep squeezing the bulb. That's our adjustable output. This one is CE approved as well. And it does the same gases and the same principle of operation. These are used, a lot of our customers have a fence line monitoring. So along the edge of their facility, they can't pollute out X amount of, say, toluene past their fence lines. So they've got an employee that walks along that fence line with this thing running, and he hits a sensor, one sensor, next sensor, and functionally tests the entire system. So that's the range of our calibrators. Again, these are on-demand generators that can be used at your facility to generate cal gas as you need it. I hope this was helpful for you, and we can turn it over to questions now.
Okay, thank you for that. If you have a question, feel free to write it in the chat box, or if anyone do. I mean, I guess I have a question, Kurt, about the relative costs of this. Without going into specifics, but is it fair to say that the initial cost is in the generator, and then ongoing consumable costs versus cylinders is often very low for the future of the instrument? Is that a fair way to look at it?
Yeah, that's a fair way to look at it. So the upfront cost is pretty substantial. If you buy our most expensive instrumentation, you're looking at about $2,500 US to get set up, and then you have replaceable generating cells after that. So you keep the instruments. You see a lot of these Cal 2000s and GENies that have been out for years and years, 15 years, 10 years. So the instruments last forever. The consumable is the generating source. And again, those are sold with different amount of hours that we sort of equate so that you can see an apples to apples. 1 hour of use we equate to one 58-liter cylinder. If you had a hydrogen sulfide cylinder that was 58 liters, and you have a 1 liter per minute regulator, it lasts for 58 minutes. So we kind of say, a cylinder is an hour.
Okay, very good. I just wrote answer one question on the chat. At the end of this, everyone who's registered will be sent a link to pick up the recording of this seminar. So you will, everyone will get that. Additionally, there are 2 documents which we're going to put for downloading if they're not already up there. Which contain further information about the product. Should be able to download those directly from the software. They're now being put up so you can see those. There was a question. So going back to the questions, can you generate ozone higher than 1 ppm? Is the first one. This question from Mark.
Yeah. We do offer that ozone generator in a fixed output, sort of similar to the Cal 2000 LT, where it's fixed and you can't change it. And in that range at at 0.5 liters per minute flow, the highest output we offer is 1.6 ppm. So yeah, it does go higher, but only up to 1.6 max.
1 point. Okay, very good. So up to 1.6. So back to the questions here. Can you calibrate multiple gases?
Well, there's one way to use these instruments is to flow. You can flow a cylinder gas through it and pick up another gas. So we do have in that sample drawing application where we say you can shut off the pump inside of the unit and then allow the calibration gas to be drawn in by the sensor. In the same way, you can say take a 3-gas mix like low oxygen, methane, and carbon monoxide, flow it into the unit, add H2S to it, and then flow that to your sensor, say a 4-gas meter. But we don't have one unit that generates more than one gas at a time. So if you need 2 gases at once, you'd have to buy 2 units from us. If you need, say, chlorine and H2S, but not at the same time, you can buy 1 instrument, 2 generating sources.
Okay. We're going to have another further question from Michael. It's to do with the annual recertification. And in particular, in this case, it's what is the situation for the ozone? Is that required to be recertified annually, as obviously Michael knows our products and he appreciates that for the GENie EC units. That's the case. To keep them, when we say required, of course, we mean to keep them to NIST traceable standards, as opposed to the fact they'll continue to work for years, but they won't be certified as NIST traceable. So the question, but this question is related, I think. I see. I think I've misread it. I think it's all the gases, in fact, and the GENie, not just those.
Yeah. So what the goal is, if you purchase one of these, you try to find a source that's going to last you about a year, because NIST, the way it works, NIST certifications expire every year. So if you have not consumed that generating source in a year, which is very typical, like in ozone, as Chris is saying, each unit and each source needs to be recertified annually. So if you when you buy a new source from us, it comes certified, so that NIST certification is good for a year, included in the price. If you haven't used it up in a year and you want to get it recertified, you have to pay for each half, for the instrument and the source to be recertified. I think that was the question.
Yeah. Okay. Thank you, Mike. If you've got any other, if that hasn't, just put another chat question in, I'll come back to it. From Bogesh, can we generate carbon monoxide, CO, and oxygen and NO? So there's a question for you. Bogesh was referring to the carbon monoxide, oxygen O2, and NO.
As of right now, no, we don't have those 3 gases, none of them.
Okay.
No carbon monoxide, no nitrous oxide, and not oxygen.
Right. Okay. I think we've had some thoughts on NO, but maybe, as we know Bogesh very well, I'll talk to him about those thoughts directly, one-to-one. From Asad Ali, do you have literature on natural gas blend for calibration?
Well, our unit, right now we don't have a methane generator. Our only combustible gas is hydrogen. And the way our systems work, to get them up to high enough, we make up to a 500 parts per million hydrogen generator. But, natural gas methane, you're looking at 2.5% by volume for a 50% LEL mix. So right now, we don't have anything up in that high of a range.
Okay. Then I've got a question from Harry. Is the bump tester rechargeable after 5 hours of use?
No, you have to buy a new generating source, but they are very low cost.
Yes.
So you throw away the old source and buy a new one.
Yeah, they're 10-hour sources. Are they 10-hour sources, Kurt? Roughly.
They're 5 hours.
5 hours. Sorry, 5-hour sources. But yeah, they're very inexpensive, those cells, compared to the other instruments. And Rika asked the question, so I'll try and understand this. Gas standards in a matrix, how reliable are they with regard to in-chlorine-like gases?
How reliable are they?
WRT with regard to in-chlorine-like gases. I was just trying to understand the question there. It may be a question to do with the standard, with the calibrations that we use, and how we.
Well, so these calibrators are NIST traceable primary gas standards. So the gas we make, and in this case is, I think the question is chlorine. It's a primary gas standard that's traceable to NIST. So it is actually the gas. We have a lot of people that think maybe we're making some kind of a simulated gas or whatever, but it's the gas that we have listed there, in fact.
Right.
They're our primary standards for that.
Okay. I've got how much from Ravi? How much hydrogen chloride as ppm level can we get from the QC 100 vials?
How much? It's usually we rate them at about 5 ppm.
Okay.
These things are not real accurate. It depends on how warm it is, but about 5 parts per million at standard temperature. In a 72 degrees or 20 degrees Celsius, it puts out about 5 parts per million each.
Okay. Is there any shelf life or expiry date for a bump tester?
There is none. No, it's just on use. So those 350 bumps or 5 hours of continuous use.
Yep. Great.
There's no shelf life on any of these cells. The limitation on them, on the sources, is always the NIST certifications, which, as Chris mentioned, it doesn't mean they don't work anymore. It just means the certification has expired. Yeah,
so for example, in our demo room where we have cells which are 10 years old, you can see the date of manufacture, and they still work. They're obviously not traceable anymore, but not certified anymore, but they still give the gas for the bump testers in particular. Yeah. Okay, from Mayank, I need hydrogen chloride cell for my Cal 2000. Is it possible, or do you have another solution for the same?
No, right now we just have, you'd have to use a surrogate gas. Most people that are calibrating with HCl are using, depending on the manufacturer of the sensor, they're either using H2S from us or chlorine and a response factor. I don't have HCl right now.
Yeah. In the only issue, do you have it in the vials?
Yeah.
So
we have bump testers for the vials, but we don't have actual calibrators for them.
Okay. Then from Reka, what's the maximum minimum gas we can generate using the ACD, and how long the standardization would persist? I think that is so. Obviously, that's a slightly different gas. There's a slightly different answer depending on the gas. But maybe you could Yeah, okay, give us some idea.
Our standard, the ratings I gave in those little spreadsheets that say, you know, it'll go from 0.05 to 50. A standard, say, calibration source for chlorine is rated at 50 parts per million maximum, and the range is 0.5 to 50. You can get a 0.05 to 5 cell if you want. So that we rate them all at a half a liter a minute of flow. If you turn the flow rate down to 0.2 liters per minute on the unit, it will allow you to turn up the calibration concentration to 125 parts per million. And if you have the flow all the way up at a liter a minute, it will only allow you to go to 25 parts per million. That's just an example for H2S. They're all different, but that's pretty common. That's a usual.
Yep. Okay. So yeah. So it's slightly gas dependent, but there is a wide range, and of course we do the micro cells as well. As you said, which take us down to 50 ppb for the most of the electrochemical gases, at least. Okay, for Mark then, can I now get my GENie calibrated, recertified in the UK? So maybe I could answer to that. The answer is yes. The main units can now be recalibrated and recertified in the south of England, when you need them, as you're in the UK as a user, in particular, you will automatically be offered that route unless there's a complication along the way. Is that fair, Kurt?
Yep.
Okay.
That's right.
Yes. So when we see particularly UK but also European users, we will try and do them that way. Therefore, saving the shipping time to Arizona and back. Question from Dr. C. If we have only 1 or 2 instruments to calibrate, say every 3 months, then the cost of the ACD gas generator is high compared to calibration gas mixture. However, a typical QC lab in a refinery or petrochemical plant has a number of safety instruments to recalibrate every 3 months. Can you give us an idea of when the use of the ACD generator becomes cost effective? There's a good one.
That's a good one, yeah. So, I mean, you know, the MiniBump calibrator, if you only need 1 concentration of cal gas, and so you're gonna calibrate at 25 ppm H2S, that unit and generating source costs about as much as 2 or 3 cylinders. So if you're using probably less than 3 cylinders in a year for H2S, you could probably just buy cylinders and you're probably better off. Anything past that, or if you have a couple of different concentrations that you need, then probably you're better off with the ACD unit, especially after the first year, because then the calibrator is paid for. But you can always talk to us and we can quote you out different systems to see, you know, what's the most economical use for it. It doesn't take very many sensors before these generators pay for themselves.
Yes, very good. Matt, then, I think is the next question. To get my GENie calibrator certified in UK, what would be the turnaround time? I mean, I would probably say with a bit of organisation and pre-planning, I mean, probably around about a week. If you're willing to get in a car and drive it somewhere and pick it up, if you're local enough, you can save some time. But I think a week is
figure a week.
A week's reasonable to allow a day in the courier each way, etc. To be honest, if you're willing to take it down and do it whilst you wait, that has been done in the past. Service whilst you wait. It's not particularly efficient use of a day, but it could be done. Dr. C again. Sometimes when we use the ACD gas generator with a sample drawer instrument, for example, safety H2S or chlorine instruments, then the calibrator does not work and switches off. Can you enlighten us how to use the ACD calibration in such cases? So with the sample draw instrument.
Yeah, so I think what's happening here to this user is he sets his instrument and his calibrator to, say, some flow rate, 0.5 liter a minute, 5 ppm chlorine. Then he hooks it up to his sample drawing unit, and that sample drawing unit is pulling a sample at a different rate. Let's say it's 0.2 or it's 0.8. At that point, my calibrator pump is fighting with the pump in the sensor. And my instrument measures the flow rate, and if it can't get the flow rate it wants, it shuts itself off. It says flow too low or flow too high, and it shuts itself off. So what you need to do is either you set the flow rate to 0 on your GENie, and then you hook it up to the sample drawing sensor. It'll read the flow rate and then allow you to set that output, whatever it is, say 5 parts per million. The other way you can do it is you can set the flow rate on the GENie higher than the sample drawing rate on the pump and put a dump T in the line so that the extra flow can go out and it can flow in at whatever rate the sensor is pulling, if that makes sense. I have a video on our website on that as well.
Very good.
Is that clear, Chris?
Yep, very good.
Yeah.
Then the next question I have is how much ppm of hydrogen chloride comes from the QC50? I think you said around about 5 ppm.
Yeah, we rated about 5 parts per million. It's all about, how fast you're squeezing that bulb and how hot it is outside. It's just a bump tester. It's not accurate, but around 5 parts per million.
Okay. And the last question I hear from there, what about flow too low and self-failure? So I think these are 2 messages that come up that we see occasionally when the flow rate is too low, or the communication to the cell in particular isn't there. Is that probably a fair summary?
Right. So as I mentioned, and as I went through the slideshow, the instruments are self-monitoring. So if say the pump in the unit can't make the flow rate that you're asking for, or if we have that example where there's another pump fighting my pump in my unit, it tells you the flow is too low. This could also be you're standing on the hose accidentally, right? It starts to beep and it says flow too low. It's to allow you to get whatever's in the way out of the way. So you can look down and go, oh, I'm standing on the hose. If you then open up the flow, then it goes back and starts to run. It does that for 30 seconds, and if it doesn't get the flow rate it wants, it shuts itself off so that you don't have an inaccurate calibration. The same thing happens on the generating sources. If the electrolyte level drops down too low, or if the generating cell is not placed into the instrument correctly, the instrument is looking at it, and it's also looking for resistance on that cell. And if any of those things happen, it'll say source failure or no source found, and it'll eventually shut itself off so that you don't have an inaccurate calibration.
Okay, very good. Okay, so from the mayor's comment as well, but that's not a question. That's just clarification of his question. Dr. C, sometimes we notice that the electrolyte during use becomes overfull and stops working. Alternatively, in dry atmospheres, the electrolyte falls below the halfway level and shuts off. Why does this happen, and how can we correct this without returning the unit for service?
Well, we have hygroscopic materials inside the instruments in the hope that they don't dry out. If the level drops down in a generating source, you can remove the caps and top them off with distilled water. What can happen on those is there's an active and passive electrode in there, and current's being passed between them. And if the liquid level drops down too low, as you're walking around, you can get that cell failure indication. So you can look through the polycarbonate cell, see the liquid electrolyte level. If it's low, you can add some distilled water. If it's high, if you live in an area with real high humidity, if it's over full, you can do the same thing. You can take the caps off, dump a little out, and let it run. So what happens, what we lose out of those sources is water. So you can add water to them and not affect the output of the sources.
Very good. And I'll take one last question from Michael here, because we're getting towards the hour. Are you able to share any future developments, such as additional gases, ranges, or devices, or maybe an ATEX rated GENie?
Well, we haven't sent the GENie to ATEX yet, so I can't really share anything with you there. But we have the next two gases we're going to have an electrochemical ammonia and SO2. So if anybody has any specifications about what ranges of sulfur dioxide they'd like from us, or if they would add an ammonia to their existing Cal 2000s or GENies, those are next on my list.
Very good. Thank you. That's a good question, Michael. Okay, I just actually I've got a 4 more minutes, so I'll try and cover the 3 questions I've got here. From Reka, we tested a long time back the Cal 2000 for chlorine generation. It was under validity and got results in errors. Cells that need to be replaced after life mentioned for it. So how should we consider to get it recertified and corrected? Maybe requires recalibration. Rick, I'll answer that in that it should give you a consistent output. Depends. If you're in India, just searching by the name, then Spantech are in India, in Calcutta. That would be your first protocol to have a discussion. Or you could come to us, because of the time difference, you could come to us in England to the technical centre we have and have a discussion. It might require recalibration, I guess, as an answer, but it might require, during the process of recalibration, it's also given a quick service course, isn't it, where you look for errors outside of the recalibration. So, recalibration is also a service MOT. Is that fair? Yeah.
Yep, that sounds right.
So
if it's an older unit, you don't need to buy any unit. You probably just need to recertify the one you have.
Okay. 2 more here. I'll just take one from Dr. C and one from Ravi. We have noticed when we use a metal head of a screwdriver, the ACD generator fuse blows and shuts off. That, I guess, is to prise the cell out of the Cal 2000. What precautions can we take to ensure that it does not happen?
Well, that's an issue for us. That we have that fuse in there for CSA, and in order to pass that CSA Class 1 Div 1 area, it can't draw much current before it pops that fuse. So, all we can ask is that you use non-metallic items to pull the batteries in and out, or drop the cell in or out of the instrument. It's one of those things that's really hard to get around.
Yeah. And we have a question from Ravi, which I can answer for you. I believe is during shipping the Cal 2000 unit with the generator cells, should we leave the cell inside the instrument and ship because it's easy? Or do you advise to remove it? I'm going to guess, Kurt, that you would advise to remove it. But also, I think just as importantly is if you're not using the instrument for a while, remove the cell and don't store the instrument with the cell inside. It's a good housekeeping well,
practice. Good practice.
Good practice, yes. Good, thank you for that.
They come in, you know, they come with the cells in the instruments all the time, and they're fine. If you have a choice, take the cell out, take the batteries out, and you know, ship them that way. So,
I thank you, Kurt. Thank you for your time. We've now reached the half hour on the dot. Unusually for us, okay. Not running late, but we're right on time. Thank you for your time. You've got your website up there. I've also put the Spantech web page up on the chat box. There's a wealth of information on both sites, technical as well as commercial. In addition, a lot of you have already done it, but if you go to the top of the screen above the chat box, you'll see the handouts tab. If you go to the handouts tab, you can download both the ACD literature, but also the Spantech product portfolio, which covers the various things that Spantech does. I would encourage you to do that. It's a quick way of picking up both detailed gas information on the generators and also on the range of services we do out at Spantech. So please do go there. At the end of this session, everyone who registered will get a link to the recording. Which please do that. And so source of questions. If you have any questions, come back to us and we will answer them. Your contacts are Spancan in India, if you're in India, or Spantech, or Kurt at ACD for other questions. We'll do what we can to make sure we answer them. That's fair, Kurt?
Sounds good.
So with that, I'll say thank you for attending. Appreciate everyone that's attended. I appreciate an hour of your time. Hopefully we've gone through a few questions and a few answers, and please, any other questions, please come to us. Thank you, and thank you everyone. I'll sign off on that.
Thanks,
thank you everyone.